right, let's talk about AI. You know, the stuff that powers Tesla's self-driving cars or the magic behind OpenAI's models. Ever wonder what's under the hood? Well, a lot of the time the answer is PyTorch. And today we're going to tear it down and see exactly what makes this thing tick, how it acts as the engine that drives AI from a crazy idea in a lab to a product you can actually use. And this quote from the PyTorch website, it really nails it. Accelerates the path from research prototyping to production deployment. What that really means is it's built for speed. It's not just about letting researchers cook up wild new ideas, it's about giving them a super fast, direct highway to turn those ideas into something real, something that works out there in the world. It's all about closing that gap between what if and here it is. Okay, so here's how we're going to break it all down. First up, we'll ask, what even is PyTorch? Then we'll dive into its core, Tensors and Autograd, the real building blocks. After that, we'll get practical and look at how you actually build and train models. And finally, we'll zoom out and explore the massive ecosystem that's grown up around it. Let's get to it. All right, first section. So what is PyTorch really? I mean, why is it the go-to tool for heavy hitters like Salesforce, Amazon, and top research labs at places like Stanford? There's got to be a reason, right? Let's dig in and find out. So the first thing to get is that PyTorch isn't just another Python library you import. No, it's more like a complete workshop for anyone building with machine learning. You get the whole toolkit, all the deep learning primitives, the nuts and bolts, and it's all designed to get a massive speed boost from your hardware, especially GPUs. And that's what makes it so versatile. You can tinker around in what's called eager mode for research, which is super flexible. But then, when you're ready, you can switch to graph mode with something called TorchScript to make it run blazing fast in production. It's also built for massive scale, so you can train on enormous data sets across tons of machines. And, of course, it plays nice with all the big cloud providers, so scaling up is a piece of cake. Okay, this right here is PyTorch's secret sauce. It's called eager mode. Now, a lot of other frameworks, they make you define the entire plan, a static computation graph up front. It's like having to submit a full architectural blueprint before you can lay a single brick. But PyTorch, it builds the graph on the fly as your code runs. This makes it feel just like writing regular Python code. It's flexible, it's intuitive, and for researchers who need to experiment and debug quickly, it's an absolute game changer. Okay, so we know what it does, but how does it do it? What's going on under the hood? Well, at the very heart of PyTorch, there are two fundamental concepts that make everything else possible. We're talking about tensors and Autograd. These are the real building blocks of AI in PyTorch. First up, tensors. So what the heck is a tensor? At its simplest, you can just think of it as a multi-dimensional array. A list, a grid of numbers, a cube of numbers. But it's got a bunch of extra bells and whistles. It's like a standard array that went to the gym and got totally ripped. This is the fundamental data structure for everything in PyTorch. Your inputs, your outputs, your model's weights, and it's built to be blasted over to a GPU for some serious number crunching speed. And look how easy it is to create one. You just write this, that's it. One simple, clean line of code. This is a huge part of why developers love it. It doesn't get in your way, it feels natural. All right, now for the part that feels like actual magic. Autograd. This is PyTorch's automatic differentiation engine. As you run calculations on your tensors, Autograd is in the background, keeping a little diary. It's tracking the history of every single operation. And why does it do that? So it can automatically calculate something called gradients. A gradient is basically just the answer to the question, if I tweak this knob, how does my final error change? It's the key to learning. So all of this comes together in what we call the training loop. It's like a simple three-step recipe that you just repeat over and over. Step 1, the forward pass. You push your data through the model and get a prediction. Then you see how wrong that prediction was. That's your loss. Step 2, the backward pass. This is where Autograd does its thing. You just call loss.backward and poof, it calculates all the gradients for you. Step 3, you use an optimizer to take those gradients and actually update your model's weights, nudging it to be a little bit better. That's it. Forward, backward, update. That's how a model learns. Okay, we've got the core concepts down, tensors and Autograd. Now let's get to the fun part, actually using these to build and train a model. This is the PyTorch recipe for making AI happen. So to build pretty much anything, you're going to live inside the torch.nn toolkit. Seriously, think of this as your box of Lego bricks. nn.module is the base plate that you build everything on. Then you have all your different pieces, the layers, like linear layers for simple connections or convolutional layers for images. Your loss functions are there to keep score of how well you're doing, and the optimizers, they're the little Lego person who actually adjusts the bricks based on that score. And what's beautiful is how a model is structured. It's literally just a standard Python class. It has two main parts you need to know. First, the underscore underscore init method. That's where you define all your building blocks, all the layers you're going to need. Think of it as gathering your ingredients. Then you have the forward method. This is the recipe. It defines exactly how your data flows through those layers you just defined. It's super clear, really easy to understand, and very, very Pythonic. Now, a model is nothing without data, right? And feeding data efficiently can be a huge pain. PyTorch solves this with a really slick data pipeline. It starts with a dataset object, which is basically a map to your raw data. But the real workhorse is the data loader. It grabs data from your dataset, shuffles it up, groups it into nice bite-sized batches, and then feeds those batches one by one to your model. It makes handling gigantic datasets feel, well, easy. So, we've covered building and training a model, but that's just the core framework. One of the biggest reasons PyTorch is so dominant is because it's not just a tool. It's the center of a huge universe of other tools and libraries. Let's zoom out and take a look at this ecosystem. And this ecosystem is packed with amazing stuff. Want to do computer vision? Don't start from scratch. Torch Vision gives you pre-trained models and standard datasets ready to go. Got a model and need to put it into production? TorchServe is built for high-performance deployment. Ever wonder why your model is making a certain prediction? That's a huge deal, and Captum is a whole library for model interpretability. And to see what's happening during training, you can hook it all up to TensorBoard for awesome visualizations. So you see, PyTorch is everywhere. It's powering everything from the language translation on your phone to cutting-edge medical imaging that can spot diseases. It really is the engine that closes the gap between a research paper and a real-world solution. It gives you all the tools. So the real question is, what are you going to build with it?